Hi students, welcome you all to my first audio visual class. Today my subject is physics. Myself, Sona Chakravarti. Today I am going to teach you class 9 physics. And the first chapter is motion. As you have a previous idea about motion in your previous classes, now today I am going to explain you a bit elaborately. Now what is motion? The things which moves, we say normally the object is in motion or things is in motion. In your surroundings, you will see different things are moving in front of you. As for example, you will see the cars, the vehicles, the animals, the human beings, the star, the planet. Even our earth is also moving around the sun, and sun is moving around the galaxy, and the galaxy is moving to each other. Now, the topics today I will explain. You just be ready with your notebook and pen to write the points which I am going to explain today. First point is motion of living and non-living objects. Point number 2, rest and motion. Point number 3, scalar and vector quantities. Point number 4, distance and displacement. Point number 5, units of distance, displacement, and after that uniform and non-uniform motions. Okay? Now start from point number 1. Motion of living and non-living objects. Living objects, you know that all the living things, we are human beings, the animals, these are all plants, trees, these are all living things. So we can see these things movement. Now you will ask how the plants and trees move. Normally you cannot see how they are moving, but they are moving. If you sow a seed, slowly the seedlings will come out from the seed, and the growth of the plant is the movement of the plant. Blooming of a birds is the movement of the plant. The branches moving towards the sunlight and the roots moving towards the soil. These all are the movement of the plants. Okay. So these are the movements or motions of the living things. Now non-living things, you know, non-living things cannot move by themselves. We make them to move by applying force. Okay? See the cars, vehicles, you are all habituated. Until we start the cars cannot move. See this one, the box. If I keep it here, it will stay years after years in the same place until or unless I push it or pull it. So when I apply force and make the box to move, that this non-living things will move. The stars. the planets, these are all are non-living things, but they all are moving, you know. A football cannot move until unless we just kick it. If you kick a football, the football will be in motion. So this is our first point, the motions of the living things and the non-living things. Clear? Point number 2, rest and motion. What is rest? See, I am sitting here. If I don't move, then I am in rest positions. If I keep the book here on the table, or if I keep the box or the furnitures in your house or in your surroundings, whatever, until unless you move or make it to move, these all things are in rest positions. Now, how will you say that one thing is in motion and one thing is in rest? A body is said to be in rest if it does not change its places by time to time. Let me clear it. Suppose I am keeping the book here. Okay. Now I am not touching the books. I am keeping the book, suppose, by 8:30. After 9:30, if I come and see, the books will be lying here as it is. It won't move. Means, so what will say? The books is in rest position. Means, from 8:30 to 9:30, in this time being, the book doesn't move. Means the book is in rest position. Then which things is in motion? Suppose by 8:30 I am sitting here, and after 10 minutes I just leave the place and goes to some other places. Means by walking, or can buy some vehicle. Means my positions or my place changes with time. Means I am in motion. So to make us understand what is the object, which one will say rest and which one will say in motion, for that we require one reference point. What is reference point? You students, you know, during the sports time, you have seen that your games teachers, before starting the race, he drawn one line, that is called starting line, and he asked you to run from the starting point, 100 meters, 200 meters, whatever else. This starting point is called the reference point. Means this is your initial positions. From these initial positions, by the time being, if your position changes, then you will be said in motion. If you are standing in the same starting line and you don't move with the type, then I will say, or we will say, that you are in rest position. Clear? What is rest and what is motion? So to explain this one, we always require one reference point. Clear? Now, scalar and vector quantities. Point number 3. You all know scalar, you have some idea what is scalar and what is vector quantity. Scalar quantities, all the measurable quantities are divided. Measurable quantities means, suppose height, it is measurable. Velocity, it is measurable. Then area, it is measurable. So now these things which are measurable, these quantities are called physical quantities. These are divided into two parts. One is scalar quantity and one is vector quantities. The physical quantities which have only the magnitude, this is called scalar quantity, and these quantities, physical quantities, which have magnitude also and directions also, is called the vector quantities. Now, in physics, in chapter rest and motion, which are scalar quantity, which are vector quantities, let me explain. Speed. Now, if you move from one place to another place, what is speed? Speed means how fast you are moving or how slow you are moving. Which directions you are going, that doesn't matter. Only measurable how fast you are moving or how slow you are moving. That part is only measurable. So, this quantity is called scalar quantity. But if I say you are moving towards north, or you are moving towards south, or you are moving towards east, or whatever else, then the measurable quantities giving the directions and the magnitude of your speed, how fast and how slow. Suppose if I say you are moving 20 kilometers per hour towards north. See, I am telling the magnitude also. What? 20 kilometers per hour, and directions also towards north. So now this physical quantities having the magnitude also and the directions also. So this quantity is called vector quantity. Now I am going to point number 4, that is distance and displacement. What is called distance? Suppose before that I already told you that from a reference point, when an object move, definitely it will cover some distance. The path, distance means the path the moving object covers within a certain time period. So the path is called the distance. Now think, from your school, if you want to go to Barakar, clear? And you take 30 minutes. Then 30 minutes, how much path you covered? That from your school to Baraka, suppose it is 10 kilometers, then your distance is 10 kilometers. Clear? So what is distance? Distance is the total path covered by a moving object is called the distance by a given time. Now coming displacement. What is the displacement? There is a difference between distance and displacement. Suppose one place, triangular place is there. You know triangle, 3. Think about, since I don't have any board, so I am trying my level best to make you understand. Think a right angle triangle. Okay? Right angle triangle. So if you want on top of the right angle triangle up, you can use 2 paths, one through 2 arms, first like that, base, then perpendicular, then you will reach the place. Or you can use the hypotenuse directly to reach the place. Now, the displacement is this. The distance between your initial and the final position, the shortest distance. If you want to go to your any place, you can use different paths. You can go circularly, you can go in zigzag way, you can use a triangular way, but these all are not be the displacement. What will be the displacement? The shortest distance. The shortest distance in between the initial point to the final point. This distance is called displacement. Now you will say, is displacement and distance both are equal in magnitude? The displacement and distance will be equal, or distance always greater than displacement but not less than displacement. Why? Because if a moving object move in a straight line, then its initial positions and final positions will be the same. Initial positions and final positions. So this is the shortest distance, shortest displacement distance, and this is the distance also, this is the displacement also, because this is the shortest path, initial point and final point, when the objects moving in a straight line. Then distance and displacement will be equal. But suppose it is this initial point and it is your final point. Now the object is moving from this side to this side from here, but its displacement from here to here only. So the distance covered in this semicircular path definitely will be greater than the shortest displacement, this distance. So that's why displacement sometimes equal to the distance wise that the object is moving in a straight line. Otherwise, displacement is always shorter than the distance. So that is the difference between distance and displacement. Now you can say, can displacement be zero? Yes, but distance never be the zero. Now giving you an example. Suppose from home you are going to school. Okay? Again you come back to your home. Suppose from your home to school is 2 kilometers. Again you come back to your home 2 kilometers. Now see, what I told displacement definition, the distance between initial and the final position. Now see, you started from home, you have gone to school, again come back and reach to home. So see, your initial point home and final point is also home. So what is that displacement? 0. But is your distance 0? I say no. Why? You have covered 2 kilometer distance up to school. Again you come back to home. Then 2 kilometer plus 2 kilometer. This is 4 kilometers. So your distance is 4 kilometers. But displacement is 0. So there is another difference between distance and displacement. The displacement may be 0, but distance may not be 0. Clear? And displacement may be negative, but distance cannot be negative. Why negative? Suppose this is your reference point. Okay? Now if you move this side, straight line, again you come back and you cross the reference point, then which side will go? Negative side. So this is your final point and this is your initial point. So now from this to this, the distance in this side will be your negative displacement, but your distance will not be negative. It will from here, then here, then here. It will add all the distance. So displacement may be negative, displacement may be 0, and displacement may be shorter than the distance. Okay? Now next, our next is the speed. Sorry, uniform motion, uniform and non-uniform motions. What is called, last point, the uniform motion and non-uniform motion. What is called uniform motion? If a body is said to be uniform motion, it travels equal distance in equal interval of times. Means, suppose a car per second, it covers distance of 2 meters. Then I will say that the motion of the car is uniform. But if the car covers first second 2 meter, second 4 meters, third second 6 meters. See, here time is equal. 1 second, 1 second, 1 second I am telling. But distance the car covers per second is different. So I will say the car is in non-uniform motion. The example, when the train approaching towards the station, its motion is going slow, slower, slowest. Ultimately it will stop. So it is a non-uniform motion. Same thing happens when the train just leaves the station and moves. Then also it covers unequal distance in equal interval of time. So this is also example of non-uniform motion. But our earth is moving in a same speed, means equal distance in equal interval of time. So the motion of the earth is, you can say, the uniform motion. If you walk 2 meters or 1 meter per second, then you will cover equal distance in equal interval of time. Then your motions will be called uniform motion. Now, accelerated motions or non-accelerated, retarded motions. If with time the distance covers by the moving object increases, as I told, first second 2 meter, second 4 meter, third second 6 meter, so it is increasing. This types of motion is called accelerated motions. Then what is retarded motions? Retarded motion is if the distance covers by the moving object is less. Suppose first second 6 meter, second 4 meter, third second 2 meter, just opposite, then this types of motion we will say retarded motions. Now my next class I will explain about speed and velocity. Thank you.